The Indian Association of Structural Engineers, also known as IAS-Struct-E, was conceptualized and constituted in the year 2002 by a group of senior professional structural engineers from all over the country. IAS-Struct-E is registered under the Societies Registration Act 21 of 1860. IAS-Struct-E is a national apex body of structural engineers in India with a mission to promote structural engineering profession and cater to the professional needs of the structural fraternity. In the short span of 2 decades, association has attained an eminent position in the professional field. Its membership is valued very highly in the profession. Since inception, IAS-Struct-E has been led by eminent structural engineers like late Shri Mahendra Raj, late Shri Shri Kumar Ghosh, Shri Subhash Chand Mehrotra, Professor Mahesh Tandon, Shri Alok Bhaumik and Shri Manoj Mittal as its president. IAS-Struct-E is a permanent member of Engineering Council of India and interacts with the government on professional and policy matters related to civil and structural engineers. To expand its reach, IAS-Struct-E has collaboration with various international professional like-minded associations and institutions. IAS-Struct-E's prime objective is supporting and protecting the profession of structural engineering by upholding professional standards and acting as a mouthpiece for structural engineers in India. IAS-Struct-E endeavor to ensure that its members develop the necessary skill in structural engineering and work to the highest standards by maintaining a commitment to professional ethics and standards. IAS-Struct-E is actively engaged in organizing several continuing professional development (CPD) courses for structural engineers to help them update their knowledge and advance their career paths. It also conducts refresher courses for young and practicing engineers and student-oriented programs. Seminars, workshops, conferences, technical lectures and discussions related to the latest technological advancements and case studies are also organized regularly for members to enable them to continuously update their knowledge and skill set by interacting with the best minds from the industry. IAS-Struct-E's activities are widely appreciated and known for quality technical contents. IAS-Struct-E is also actively engaged in publishing its quarterly journal Structural Engineering Digest (SED), code commentaries, professional guidelines and a monthly newsletter. IAS-Struct-E's publications are becoming popular with time. IAS-Struct-E has representation in various technical committees of BIS and IRC as well. Its members are actively contributing to National Code of Formulations. In the year 2020, IAS-Struct-E started National Awards competition to stimulate interest in the structural engineering field and to promote innovative thinking and creativity. The awards are presented to the winners in recognition of their outstanding contribution to structural engineering in the categories which include Outstanding Structure, Outstanding Structural Engineer, Outstanding Woman Structural Engineer, Promising Young Structural Engineer, and Best Master's Thesis in Structural Engineering. IAS-Struct-E is currently operating from 4 regional centers, namely Eastern, Western, Northern, and Southern, having its headquarters in Delhi to inculcate the professional culture and provide handholding to the budding engineers. IAS-Struct-E has its student chapters in several leading engineering institutions as well. Membership of IAS-Struct-E is open to all civil and structural engineers engaged in structural engineering profession. Members are elected based on their qualifications and experience in different grades as per eligibility requirements prescribed in the bylaws. Each application is carefully scrutinized before electing the members. More information about IAS-Struct-E is available on its website www.iastruct-e.co.in.
Shall we start?
Yes.
We should.
Shall we start or wait for some time?
No, please start, sir.
Okay. Friends, first of all, a Happy New Year. because this is the first monthly lecture in the new year, and that too by our great speaker, Dr. Lakshmi Parmeshwaram. The brief about the topic is, we all know the climate change and induced environmental effect are being experienced by most nations across the globe. The adverse impacts of disasters arising as a result of climate change pose several challenges in the construction and maintenance of transportation infrastructure. Therefore, it is essential to incorporate factors reflecting the extreme weather variations while designing bridges. Now, we all know Dr. Lakshmi Parmeshwaram has been a former chief scientist in CSIR, CRI, New Delhi, and currently works as an independent researcher. She has a rich experience spanning for over 35 years in research, academics, and consultancy, and is a member of various Indian Road Congress and BAS committees. Her areas of specializations include wind-resistant design of long-span cable-supported bridges, chimneys, cooling towers, and communication towers, development of BMMS, structural health monitoring of bridges, performance evaluation, and rehabilitation of bridges and sustainable construction materials. Now we have got again renowned moderator, Mr. V.N. Hegde, who was former Chief Executive Officer of Stoops and former Executive Director of Gammon, is currently an independent consultant. He is a senior professional with rich experience of over 30 and a half decades in construction sector. Mr. Hegde has a rare distinction of being equally adept in structural design and construction. Now I request Mr. V.N. Hegde to take over and conduct the session.
Yeah, thank you. Thank you, Dr. Dhawan, for this nice introduction. And friends, welcome back to our monthly webinar. As Dr. Dhawan has explained, one of the gifts of the COVID is, that we have all become very conversant in attending the webinars and seminars and symposiums on webinar these days. And also it has improved our sustainability aspects. This particular, this monthly presentations was organized by Delhi Center, especially led by Dr. Dhawan, every month physically earlier prior to the COVID. But after the COVID, it was decided to, go through the webinar mode because it will have a long reach, the broad reach to the all over India. This webinar could be attended to. And also in a way, ironically, you can see that the gift of this COVID has improved the sustainability. Most of the people who are there in Delhi would have to travel to this venue where the presentation normally would have been to be made. But imagine all those people who are traveling by the cars don't have to travel. They can be in their offices, they can be at the houses, and they can attend this kind of webinar online. That itself is a it furthers the cause of sustainability indirectly from that point of view also. So much carbon dioxide emission to the environment is stopped because of not traveling by their individual cars and so much. That is helpful. Talking about today's topic, the sustainability, I think some days before, earlier days, there was a debate as to whether there is a concept of climate change. It's just a myth that kind of debate was going on way back in perhaps 3 to 4 years back, led by, I think, the United States of America, President Trump himself. He was, not very convinced that because of the climate change, there will be an increase in the temperature to the extent, and it will cause the climate change effects like super cyclones, change the precipitation pattern, floods, droughts, wildfires, landslides, melting of ice, glaciers, as well as the avalanches. Some of them we are really witnessing in India itself. And even in India, you can see that a lot of, the cyclones are taking place, and a recent phenomena which took place in Gujarat may not be exactly directly the climate change effect, but can't say. In my opinion, it's very difficult to predict that. But the climate change has become a reality. This is not no more a sort of a myth which has to be burst, and whole world is talking about it. And in fact, in this connection, as all of you are aware, there were two important meetings. One in Paris, which was called as COP21 in 2015, and the another was in Oslo in 2021, which was called COP26, where the world leaders made some commitments to the cause of the sustainability, so that our posterity enjoys the natural resource benefits which we have been getting. That in particularly the commitment which is made in COP26 by India is very, very important. Our Prime Minister Modi gave the Panchamrita, what you call it as, and he said he was committed to reduce the economy's carbon intensity down by 45% by 2030, enhance the non-fossil energy capacity to 500 gigawatt rather, and 50% of the energy requirement through renewable energy, and reduce 1 billion tons of carbon emissions. In fact, whatever the commitment which was done in Paris earlier in COP21, to the most of the, to the surprise of the world, the India was the country which achieved much of the percentage of that commitment that. And also our Prime Minister committed by 2070, we will be achieving the carbon neutrality. How it is relevant to us in terms of the construction, let us have a look at it. Now, in the construction sector, even in India, comparable to that of the world itself, the carbon dioxide emission which takes place to the environment is around 12.75%, whereas the operation, what they call it as a carbon, that is because of the operation of any facility for that matter. For some reasons, if we have to spend the energy, again, the energy productions, since it comes from the fossilized fuel resource, again, it adds to the carbon dioxide emission to the environment. That accounts for 17.5%. Now, today's topic, our Dr. Lakshmi, I think she's very well known. Her introduction was already done by Dr. Dhawan very efficiently. And she's as he said, that she's a former chief scientist of CSRI, and presently practicing as independent. And she has been in the cause of furthering the cause of the standardization in the country, especially in IRC, Indian Roads Congress. She's a member of so many committees. I think she herself may not have kept the count of it as to how many committees member she is. And though she is not today to the that well, in the sense to the extent she's not fully well, and she's undergoing some sort of problems, even then, despite the health problems, she has accepted today to come and as committed by her to deliver her presentation on the sustainability aspects, especially the climate change aspects relating to the bridges. And also she's not going to talk about what are the effects of the climate change on the bridge construction, in particularly in the construction as far as the bridge operation is concerned, but also she will be deliberating on some climate actions aspects. In the sense, when you say climate action, whatever the climate change effects to overcome whatever the measures we take it as are called normally in terminology of the sustainability is the climate action. She also should be talking about some of the climate action propositions and in our presentation. And with this small introduction to the topic of today, I will invite Dr. Lakshmi Parameswaran to give her lecture and some small housekeeping tips. And please raise your questions in the question and answer bank, not in the chat box. We'll be taking the questions which are put in the question and answer banks only, not in the chat box. So at the end of her presentation, I think we'll be having a discussion, taking the questions. And for discussing that, we also have got our very well known, eminent engineer, Mr. Alok Bhaumik, and all of us will be debating that while taking the question and answer at the end of this session. With this, I invite Dr. Lakshmi to take the virtual podium and deliver her lecture. Dr. Lakshmi, it's yours.
Thank you very much, Mr. Hegde, and for very nice introduction to the topic. I think most of the things like you have, I think, given in the beginning. And I would like to thank Dr. Dhawan, who I think in his usual manner invited me almost 6 months back to deliver this particular lecture. And I started collecting material and reading at that time. And then I thought that, okay, I should give in this new year some effort I should put and give a new topic to be presented. So that's why I opted for this particular topic. And I am thankful to Mr. Alok Bhaumik and IAS Struct-E, all professionals, and also all the participants who have taken time to attend this particular webinar, which is very important, not only for the engineers, but also for the students who are now doing engineering, who will be anticipating more effects of climate change in the future. So I think about this background already Mr. Hegde has given. Basically, it is the Paris Agreement, which was adopted by that COP21 in 2015, which resulted in a fresh wave of climate action around the globe. And the scientific community and policy makers were compelled to enhance the resilience, mitigation, and adaptation measures to address climate change. In India also, if you see that, like many organizations, they are doing research in this particular area, and many educational institutions, starting from IISc, IITs, and other institute also, now like this climate change, that has become a topic of research. And some of the institutes, they are offering some courses in the graduate level also. Why this is happening is to face the commitment which we have made that by 2070 we will be net zero. Then climate change planning, that became the central point of these measures and became a prerequisite to coordinate with global actions to address the climate change. And in India, basically this Ministry of Environment, Forest, earlier it became Ministry of Environment, Forest and Climate Change. And what they are doing is like every state, they prepare the state action plan on climate change, and then they synthesize that at the national level. So in 2019, what they have directed is that the states, they have to envisage inclusive and sustainable development along with climate resilient, low carbon development. As Mr. Hegde has explained, that we have promised to be net zero by 2070. That means that by that time, we will not be adding to the amount of greenhouse gas emissions in the to the atmosphere. So this is a brief background. And coming to the bridges, at present, are we considering the climate change like for the design? I don't think we are including that, though we consider many of the environmental aspects. For example, we consider the temperature for the design of bridges, we consider cyclone, we consider the flood, we consider the rainfall for the hydraulic design. So many of the aspects, though we consider, but we are not considering the climate change for the design of bridges. At present, like we have the design features as per the IRC 5 guideline and load combination, because we are following the limit state design. So it is given in IRC 6. So there, like apart from like your dead load, live load, like we have other number of loads to be considered, like water current and cyclone, wind effects, earthquake effects, temperature effects. So all these things like one has to consider for the design. So they are basically based on the IMD data, which has been collected over the years. And IMD has prepared the maps which are given in BIS standards. For example, wind map, which is given in IS 875, that forms the basis for the design of bridges. That means like we have different zones, and where we have specified, you can see that 33 meter per second or 39 meter per second, that is single value has been specified for wind at a particular location. So like similarly, like we have the earlier we were having the maps of isotherms giving minimum and maximum temperature. Now that has been replaced by a table giving like what is the maximum temperature at a particular location, minimum temperature at a location. So those things are being used for the design of bridges, and also some temperature gradients are given for the design of bridges. Then like we are doing the limit state design of bridges, especially the concrete bridges as per IRC 112, where rather than the strength, the durability aspect has also been considered. And we are considering the exposure condition at the location of the bridge to decide about what type of material to be used for the design and how much cover to be given and what should be the grade of concrete to be given, whether any additional measures such as some different type of reinforcement like galvanized steel or like epoxy coated bars are to be used. All such things are covered in this limit state design code. Then there is a limit state design code for steel bridges like IRC 24, and also a steel concrete bridge as per IRC 22, and the foundation design that is being done as per IRC 78. And there are other codes like for the bearings of the bridges IRC 83, and then for expansion joint IRC SP 69. Apart from this, there are some special publications which are there for the design of like pre-stress, precast pre-stress girders, pre-tension girders, continuous bridges, voided slab bridges, etc. So this is just a background about the bridge design. And in this particular presentation, I'll be focusing on the climate change induced environmental effect. Then what is the significance of this climate change on the design of transport infrastructure, and then especially for the bridges, and how it affects the performance and the adaptation and mitigation measures. Basically, if you start with the definition, as per UN, basically climate change refers to long-term shift in temperature and weather patterns. And this climate change can happen either naturally, but since 1800, because of our activities, the climate change has been happening primarily because of this burning of fossil fuels like coal, oil, or gas, which produces heat trapping gases, which we call this GHG. Then anthropogenic climate change, that is defined by human impact on Earth's climate. And this IPCC, that is the Intergovernmental Panel on Climate Change, that has defined climate change as any change in climate over time. This we have to see, that is over time, whether due to natural variability or as a result of human activity. And I'm now focusing only about our country, like how this climate change is affecting the various extreme events. For example, if you see this particular graph, you can see that like there are some flood and the frequency is 28 number. Then comes like unprecedented storms and cyclones, that is 10 in number. Then unseasonal rains 7, heat wave 7. Then there are other events like drought, flash flood, or that is cloudburst accompanied with flash flood, then cold wave condition, heat wave, forest fire, lightning, etc. But that frequency is reducing. So the most important event that you can see that it is flood and subsequently by these storms. And also if you see over the years, that you can see that most of the years the event has happened, and in some of the years the event is as many as 10 numbered. Okay, so that means we generally consider that when we do the design, maybe like we have the return period concept, and we consider that for design of the bridges, like 1 in 100 year, 100-year return period for the flood, or 100-year return period for the wind, etc. That is, in the probability of occurrence of that particular phenomena is 1 in 100. But if you can see that many of these phenomena, they are occurring more frequently. That means that the return period concept, whether we can adopt for the design, that itself is questionable. Then comes like being the flood being the important phenomena. I just tried to explain a schematic diagram presenting the various causative mechanism. Actually, like we have flood that can happen in an urban area, or it can happen in our river, and we have rivers which get water from the rain, or which get water from the melting of the ice, snowfall and ice, etc. And then there could be some coastal flooding. So if you see the urban flooding, the reason could be the drainage system, or the land use pattern has changed because of the urbanization, or there could be some problem with the dam management, or there could be some extreme rainfall event. And also you cannot forget the soil properties, how the basin characteristics are changing. So you can see that these aspects, for example, drainage system, land use change because of urbanization, this dam management, these are our human flaws. That is what we said, that this climate change is happening because of our own action. Okay. Then comes the river. Again, like you can see that it could be the flood in the river, that could be because of the dam, or because of the extreme rainfall event, or the soil properties, or some tropical storms, or their glacial and snow melt. You can see that now in Himachal and other parts, there are so many snowfall happening. And then comes the coastal surge. It could be either due to this tropical storms, or because of, again, the snow melt, or the sea fall rise, or the coastal tides. So if you see this blue box starting from the extreme rainfall event, again, these are because of this anthropogenic, that is the phenomena caused by the human activity. And here you can see that again, there are some tropical dynamics, because you will see that to understand the climate change, basically you will have to take the help of one meteorologist also. So far, like we consider for the bridge structures, like we say that we need geotechnical engineer, we need like structural engineer, hydraulic engineer, like geologist, etc. But here, like you will see that we may have to consider consult a meteorologist also. And in this regard, I would say that there is one book, that is Assessment of Climate Change over Indian Region. This is a report of Ministry of Earth Sciences, available in internet. I think those who are interested for more details, they can read this book. And here, just I would like to explain just 2-3 small terms. You will see that there is one term called IOD. Basically, this IOD represents some Indian Ocean dipole, where it talks about some irregular oscillation of the sea temperature. And you will see that there is one ENSO, that is El Nino Southern Oscillation, which talks about the change in temperature of water of central and eastern Pacific Ocean. And there is another term called MJO, that is Madden-Julian Oscillation, that is a major fluctuation in the tropical weather on weekly to monthly basis, especially related to the cloud and rainfall. So you can just understand how this climate change is happening and what is the factor which leads to a particular extreme event. Now, how IMD, because for our country, like we follow what is defined by Indian Meteorological Department. So they have identified some 7 group of climate change induced extreme weather events. So one is the snowfall. Basically, it is a hydrological hazard, and it affects the transport, it affects the crop, it affects the people also. Then lightning and storms. As I showed you in the previous slide, we have some events of lightning that is also happening. And storms, basically, like in northern part, we have these dust storms, then thunderstorms and hailstorm, which is accompanied with heavy wind speed also, high wind speed also. Then heat wave condition is also there. And this condition signify a certain amount of rise in temperature at a given place with respect to the normal climatological value. Then cyclones are there, and earlier India has a vast coastal line, and we used to experience a lot of cyclones in the eastern coast. But now we see that even in the western coast, like we are experiencing these cyclones. Then comes some of these aspects, they have defined the severity also. That means like we have to understand what are the extreme events and how the severity of the extreme event is defined. So if you see the heat waves, basically the severity means it is a heat wave condition, that is a normal heat wave condition, that is 4.5 to 6.4 degree departure of the maximum temperature. And severe heat wave, it means the departure of the temperature is more than or greater than 6.4 degree centigrade. And heavy rainfall is that in 24 hours, like if you get 64.5 to 115.5 millimeter rainfall, then we say it is a heavy rainfall. And 115.6 to 204.4 millimeter in 24 hours, that is very heavy rainfall. And extreme rainfall is more than 204.55 in 24 hours. Then this cloud burst, basically, it is a very heavy rainfall, and it is, you have to see here, it is not in 24 hours, but in 1 hour, if you receive more than 100 mm, that is over a localized area accompanied by some lightning, etc., then we call it as cloud burst. Then similarly, like you have cold day, where like you see that the maximum temperature drops by 4.5 to 6.4 degree, and severe cold day, where the maximum temperature drop is more than 6.4 degrees centigrade. And a cold wave condition, we say that where the minimum temperature drops by 4.5 degree to 6.4 degrees centigrade than normal. And severe is the minimum temperature drops by more than 6.4 degree than normal. So that means like they have defined the various events that are happening in our country, and also the severity has also been described by them. And I would like to show you like 2 charts. These are from the RBI Bulletin 2020. You can see here that this chart basically gives the variation in the temperature. You can see that this blue is basically the mean annual temperature. That is from 1901 to 2016. Okay. And here you can see that there is one black line, like which dotted line, which gives the average temperature between 1971 to 2000. So you can see here that the mean values in some of the years, they were quite lower earlier, but you can see that now like the mean value has changed. It has increased. Okay. That means there is a volatility in the temperature event. And you can see that how much volatility is there. It is something like 1901 to 20. That is every year. If you see, earlier it used to be like 1901 to 1920 and 1921 to 1940, it was only 0.18, but it has started increasing, and something like 2001 to 2017, if you see, it has increased to 0.54. That means temperature volatility has been measured using standard deviation. That means like the mean is also changing, and also the standard deviation, that is also changing. So you can see here that there is a change in the temperature, and also the volatility is changing. Now, I just want to explain this particular graph. Actually, when I talked about that the wind speed, what we consider that the single value, basically we assume that though it is a time varying phenomena, for the design, we assume that like it has a stationary mean and standard deviation. But with the climate change, what is going to happen is that it may be a stationary mean, but non-stationary standard deviation, or it may be a non-stationary mean with a stationary standard deviation, or it may be a phenomena with non-stationary mean and non-stationary standard deviation. And you can see from the previous chart that the mean is also changing, and also the standard deviation is changing from time to time. So this aspect is very important, and we may have to incorporate that for our design. And also we have to identify right now, like we have some map, like wind map, we have earthquake map or temperature map, like that. And also, like you can see that which are the cyclone prone region, like the wind map definitely gives how many cyclones have occurred in the eastern coast and western coast, and how much are of severe cyclones have happened. But here you can see that some dark color shade, that is the highest occurrence of cyclones reported in 1998 to 2019. And you can see that it is there in the eastern coast and western coast. And you can see that even the heat wave that has also occurred, like in Andhra Pradesh, Orissa, etc. And also like Tamil Nadu, you can see that there is cyclone prone region and also heat wave prone region. And even you can see that Rajasthan, Gujarat, Maharashtra, Madhya Pradesh, West Bengal, Himachal Pradesh also is one of the state having this heat prone event. Then you can see that there are major flood prone states. You can see here like Maharashtra, Gujarat and Assam, Bihar. We hear every time from the newspaper and the TV channel that they are suffering a lot of flood. But the other states also, like many of the states, they are prone to floods. And you can see that this unseasonal rainfall, that is also has become one event, and Maharashtra has this problem. So if you see here, Maharashtra is subjected to flood as well as this unseasonal rainfall of the highest occurrence you can see here. And the other states like Karnataka, they are also having unseasonal rainfall and also some flood happening in other states. So we have to understand them, and also maybe we have to consider, rather than just a complete India map, we may have to study each of these regions in more in depth to understand how the like climate change is affecting those regions. Now, this is another interesting graph which I would like to present, where like you can see that what is the projected changes which are likely to happen with respect to the annual precipitation, surface air temperature, and change in summer monsoon precipitation, sea surface temperature, surface air temperature. Here you will see that there are two aspects mentioned here. One is this RCP 4.5 and another is RCP 8.5. I just want to explain what is meant by this RCP first. Basically, RCP is the representative concentration pathway, is GHG concentration trajectory, which is adopted by IPCC. Basically, IPCC consider 4 pathways, that is RCP 2.6, RCP 4.5, RCP 6, and RCP 8.5. What is meant by that is RCP 8.5, basically it refers to the concentration of carbon that deliver global warming at an average 8.5 watts per square meter across the planet. And when it comes to RCP 4.5, it is basically a scenario, that is, it is a stabilization scenario, which means that the radiative forcing level stabilization is at 4.5 watt per meter square. That is by employing the strategies for reducing GHG emission. That means if we don't adopt any GHG emission measure, then we will be having something like 11.4, that is by 2070 to 2099, that is 10 to 20 range. There will be change in the annual precipitation percentage. That is, there will be some 11% more precipitation will be there. But if we adopt some strategies, we are able to means force it to a level of something like 7.2. That means the blue ones, the blue ones, or you can see that the RCP 8.5 is like the maximum which is likely to happen if you don't have any measure adopted. That is the highest baseline emission scenario in which emission continues to increase in the 21st century. And RCP 4.5, that is a moderate scenario where, like, if we adopt some emission, then how we can reduce that particular event. So these are some of the projected changes over the Indian region, which we may have to consider again for our design. Then now comes to the climate change, why it is important for the transport infrastructure. In fact, rather than like we focus only on bridges, we may have to consider the entire road network for this particular study. Why I think so is that basically the road network has, like you can say the flexible pavement, you can say the rigid pavement, some embankments are there, some bridges are there, some flyovers are there, some underpasses are there, and some culverts are there. And each of these components, they have actually, if you see, different design life and different materials are being used for the construction, and also the soil characteristic, they are changing from place to place, and also the groundwater level is also changing. So there are certain, if you consider a road network, like even one portion of the road network is affected, then like the road users are affected, they may have to detour, or the road user cost is likely to increase. Okay. And but of all the structures or all the elements which are there in the road network, basically the bridges, they have like 100-year design, like that is what which we are considering right now. So when you are designing a structure for 100 years, definitely the climate change is also one important aspect to be considered in your design. That means, like just like you do an environmental impact assessment for the road network also, you will have to do a climate change impact assessment study and then adopt mitigation measures or adaptation strategies have to be included. So you can see here, like what are the likely effect to be there, that is changes in the rainfall, temperature and evaporation patterns can alter the moisture balances in the road pavement foundation, rise in the water table that can lead to the reduction of structural strength of road pavement, leading to the damages of earthwork, embankment and drainage system, rise in air temperature and temperature extreme that can accelerate the aging of road surfacing bitumen layers, leading to surface cracking, migration of asphalt and rutting, and increased rate of wear and tear. In fact, if you see a pavement is cracked, and there will be a lot of difficulty to drive over that particular pavement. And the rise in temperature extreme that impact the concrete construction practices, because we have cold condition construction practice, then hot weather construction practice, and there will be, because of the concreting itself, like there will be some heat of hydration is there, so it is, the cracking is likely to happen, that can affect the durability of the structure, and also the thermal expansion of the bridges to cater that we provide the bridge expansion joint, so their performance can also be affected. When that is affected, even the bridge bearing performance can also be affected. And you can see that some of the support condition changes, and you can the bridge itself can experience some distresses. Then increases in precipitation and increase in intense precipitation events can cause overloading of drainage system, because that is another aspect. Because whenever there is a rain, especially in Delhi, we've experienced a lot of like you can say urban flooding because of the malfunctioning of drainage system, especially like the underpasses which are being opened. Like you can see that the drainage systems are many a times they are not working properly, so causing backups and flooding and increase in the road washouts. And as I said that if you in a road network, even some portion of the road washout happens, then it create a lot of problem to the road users. And changes in seasonal precipitation and river flow pattern induce increased risk of flood from rain runoff, landslides, slope failure, damage to road and bridges. This is one like flow chart where you can see that all these events like the extreme rainfall event, heat event, total monsoon rainfall event, average seasonal temperature, etc., how it affects like the various aspects, and also like how it damages, that is the damages or the direct effects to the road, bridges, railways, etc. And not only that, it affects the climate change effect will have effect on the vehicle itself, that is the diesel engine, etc., that they will also get damaged. And the green ones, what is here, these are some of the adaptation method, that is the improvement of drainage, or you can have some construction or improvement of power lines, etc. And the secondary effects are like if some road is affected, there could be some more traffic jams there, or interruption of emergency services, etc. Really, if you want to explain this, I think it takes a bit more time. So I'm just skipping, as I have already explained many of these phenomena. Here also you can see that like the vulnerability of transportation system itself, that is, it depends on the, it is directly related to the floods which are happening. And because of the floods, what is likely to happen, that is inundation of surface and subsurface infrastructure, undermining of bridge foundation, then corrosion from salt water, so increased cover around the bridge footing. So these are some of the aspects which are likely to happen with respect to the bridge structure. And again, like there could be some temperature related events which can result in the pavement damage, or which can lead to the, you can say that some freeze and cycle can happen, that also can like cause the permanent damage of pavement, road, runway, railway, etc. And because of this infrastructure impact, the operation of that particular road is also affected. For example, if there is a pavement damage, the traffic speed is affected. And what is the adaptation measure is that the frequent maintenance may be required. You may have to milling the ruts, because the flexible pavement, we generally design it for rutting and the fatigue phenomena. And you can say that like you may have to adopt some heat resistant bitumen. So these are some of the measures which we can adopt for. Then the water related also we have discussed about, like the subgrade can also be affected. There could be some erosion and decay, and that can lead to the instability of the tracks, especially for the heavy vehicles, and improvement of remote sensing technology. Those things can also be used for this particular as an adaptation measures. And there are many literature available in this aspect, and probably the climate change aspect, that is the environmental effect aspect, we will have to focus on what is happening in our country. But the adaptation strategies or mitigation measures, like we can have a look on what the other countries are doing, and some of them appropriate, we can also like use them. And like just like when we go to the bridge and see the various conditions, we try to rate that condition of the bridge. Similarly, like we can also do how sensitive a particular structure is to climate change. So whether it is not sensitive or there is a low sensitivity, this yellow color, that is localized infrastructure service disruption, but no permanent damage. But moderate sensitivity means widespread infrastructure damage and service disruption, and partial damage to local infrastructure. High sensitivity means permanent or extensive damage, which is requiring extensive repair. So these are the 4 levels of sensitivity to the climate change. And you can see that in the case of bridges, like both large scale and the small scale bridges, basically they are more prone to this extreme precipitation and flooding. That means as per this particular high sensitivity, that is permanent or extensive damage requiring extensive repair in the case of small and large scale bridges. But you can see that even like there is moderate sensitivity to the bridges because of storm surge or sea water level, or because of the damaging storms, or like snow, ice, etc. And even the large scale bridges, this extreme heat that is affecting. So you can see that they are, most of the cases, they are all sensitive. You can't say that they are not sensitive to climate change. And with respect to the material, what is for the construction, like you can have concrete. Again, the concrete is affected by the cyclone, storm, sea level rise. Then the metal or the steel bridges, they are also affected. And you can see the mortar, they have like moderate effect. You can see there are nowadays some coatings are also being used. So whenever we use a coating for the bridges, we have to also see whether like they are susceptible to the differential impact of the climate. You can see that some of these coatings like polymers, like FRP material and all, they are more prone to this ultraviolet radiation. So that means like we have to understand whether it is a bridge which is susceptible to what type of activity, and the material, what we have used for the construction, how it is prone to the climate change. Now we can see that like the accelerated material degradation that can happen because of high temperature, increased precipitation, relative humidity. And you can see that because of the carbon dioxide present in the atmosphere is going to increase. So there could be deterioration of concrete bridges due to carbonation. Then plastic and rubber, which is used in the bridge, they will be having the ultraviolet B component of solar radiation. There could be some biodegradation of structural component made of concrete. That is the freshly poured concrete that has generally 11 to 12.5 of pH, but that pH which prevents the growth of bacteria. But when the pH get reduced, then that support the growth of bacteria. So the excess carbon in atmosphere due to changing climate that result in faster rate of pH drop, and also it will help to grow the bacteria more in the concrete structure. Then damage to pavement and rail, I have already explained that there could be deterioration due to heat wave or frequency and intensity of rain. And we have some road rail bridges, and these bridges, they are having rail also. So the rail also could be subjected to some lateral buckling, and there could be rail deformation, and these things can lead to rail traffic disruption and accident due to the heat wave impact on the rail. Then the frequent floods and higher flood level, that can also like lead to some increase in the precipitation in some region, and also increased flooding risk that can happen. And there is one interesting study which in Canada, because Canada is one country like which has anticipated and which is experiencing a lot of climate change. And in fact, Canadian Standard 2025, they are going to incorporate this climate change as one of the aspects in the for the design of bridges. So a numerical simulation study there, they have found that two of their bridges, they will be submerging between 2040 to 2060. So maybe we also will have to do some studies to find out, especially in the coastal area, whether some bridges are likely to get submerged, because the level of the deck, high level bridge, the level of the deck we have fixed at a particular level, but whether that is sufficient or not, that is very important aspect. Now coming to different measures like the mitigation and adaptation measures, that is the possible risk management measures. Actually, I have already explained that the reduction of this greenhouse gas emission or like reducing the vehicle mile traveled. For example, today, like we are participating this webinar and not traveling. So that means like we have tried to reduce the GHG emission. Okay, so that is the, we have to consider the hazard. Then we have to consider the exposure because of this event. And then like how vulnerable is our structure to that particular event, that has to be ascertained. Then we have to see the consequences and whether we can increase the adaptation measure for reducing the effect of this particular environment. That means like there are different strategies, and they are termed either as climate change mitigation measures and the other as the climate change adaptation measures. So if you see the climate change mitigation measures, basically we have to identify what are the GHG emission sources. For example, like it may be from the power generation, transport or construction or industry, etc. Maybe like we can have some renewable energy based electricity project, then energy efficiency improvement in industries. Actually, a lot of things are happening, especially in the cement manufacturing industries, like to reduce the carbon emission. Then transmission and distribution infrastructure improvement, and rather than the oil-based or gas-based vehicles, we switch over to the electric vehicle. So these are some of the climate change mitigation action. And in this regard, I would say that there is IRC SP 133 2022. That is a guideline on reducing carbon footprint in the road project. Basically, it has 3 parts. And the first part is about it gives an introduction, and also it includes the methodological approaches as per IPCC for GHG emission estimation. And part 2 gives the GHG estimation methodology and GHG efficient technologies for both road construction and maintenance. And the third is GHG estimation methodology for vehicular emission during operation stage of the roads. That means the road construction, maintenance, as well as the operation of vehicles over the road, on the road. So from these three, like there could be some emission. So how this GHG emission, how it can be estimated, and also what technology we can adopt. These things are given here. Now I will quickly go through this potential climate change impact and possible adaptation strategies. First thing I discussed about this accelerated degradation. That is, I said that there could be carbonation, there could be biodegradation, etc. So in design, basically what we can see that increase the concrete cover thickness or improve the quality of concrete, strength grade, or you can have some protective surface coating. Then stainless steel bar can be used, or galvanized reinforcement, or some corrosion inhibitors can be used. Then some electrochemical methods like chloride extraction or cathodic protection can be done. And also the structures need more frequent inspection and maintenance. Then we have some periodic inspection and monitoring of bridges for increased long-term deformation of the bridges. With respect to the pavement, basically polymer body modified binders could be used, or there could be some new heat resistant paving material. In fact, in India, we have this viscosity grade bitumen like VG30, VG40, etc. So such things could also be used. Then with respect to the flooding, like we can have flood proofing or flood control, sea walls, etc. Then what should be the level of the bridge deck? Then also real-time monitoring of the flood level. So there are different adaptation strategies. So one have to really think for a particular project what can be adopted. Similarly, this upgrading the drainage system and increasing the standard of drainage capacity of the bridges. These things are also very important because many cities, we face these floods on the road after a rain. Then wind-induced loads, like you can have some geometric modification, or you can have some dampers, etc. provided. So there are, or some mass reduction, etc. So there could be many methods by which like we can make the structures safe. Similarly, for the increased cover rate, because we have identified flood as the major problem. So there could be a covered, and you can have some riprap or like partially grouted riprap, concrete block system, or Gabion matrices, etc. They can be used as adaptation strategies. And in this line, like I would like to just give this, there are two IRC guidelines, that is guideline for design and installation of Gabion structure, and guideline for design and construction of river training and control works for road bridges. So these things can also be referred for this particular aspect. Then there could be some, with the rain, there could be some side slope failure and landslide, and adequate stabilization measures have to be adopted. Foundation settlement could be one problem, or rockfall, especially the Mumbai Pune Expressway, there are many rockfalls. So there are some energy dissipating protective structures for bridge piers or attenuator fence system, like that. There are many measures which can be adopted for the as adoption strategies. So we have seen that what are the extreme events because of the climate change, and how it is affecting the transportation network as such, and why it is important for the bridge, and how we can incorporate or consider this, and also like what are the mitigation measures and the adaptation strategies. And as a way forward, I would say that the climate change induced environmental effects needs to be studied more in depth at regional level, and rather than this return period concept, because these are now frequently occurring phenomena. So this non-stationary time varying action that needs to be considered for the design. Climate change impact assessment studies for road projects, that is including bridges, because even if you see the DPR, we prepare one DPR for the road, and there is one DPR manual that is for the bridge. But I think we have to consider them in toto, and also we have to see that the design life of various components are different, various structures are different, and even in bridges, you can see that the design life of the bridge and design life of a component like expansion joint or bearing, they are different. So those things also one has to take into account. Then carbon footprint estimation, both projects with and without mitigation strategies will have to be done. Then adopt appropriate adoption strategies to enhance the performance of the bridges. This is what I think, and this is a, you can say, a preliminary study made by me, and I'm sure that I'm not a meteorologist, a structural, whatever I have presented is from a structural engineering point of view. I'm sure that there will be many participants with various backgrounds, and I'm sure and I'm happy to receive some comments from you. And also, if somebody is interested to join in this particular study, you are most welcome. Thank you very much.
Thank you, Dr. Lakshmi, for that very insightful presentation. In fact, it's a need of the hour these days. You have so beautifully explained this after effects of the climate change and some of the climate action which has to be taken into consideration in designing of the bridges so that we can overcome. And also, I think there are two aspects to it. One is achieving the carbon neutrality by 2070, especially in the bridge construction. There, the decarbonization aspect that you have just touched upon, I think there's a lot of work to be done on the decarbonization aspect, especially, you know, like the how carbon dioxide or a greenhouse gases, what you call it as, majorly it is majorly of that of carbon dioxide emission to the environment, basically. How do we achieve it by carbon, how to achieve this carbon neutrality by 2070? In fact, you have got a lot of insight into this climate change after effects in terms of how to overcome this by the designing the resilient structures, you know, like to take care of this, you know, if it's to be taken, it has to be designed, first of all, assessment of the volatility of the temperature and the volatility of perhaps the wind induced forces also, and also the effect on the hydrological design, including the scar depth and the water table variation, which was normally found, but it's going to be changing. All those things you have very well explained. As you rightly said, it's an evolving thing as far as India is concerned. All of us are working on that. And in fact, I'll tell you that IRC is also, in addition to this SP 133, IRC 133, IRC is also working in two ways for the as a climate action. One is that we are working on this one, what we call it as a IRC 5.3 committee, that is working on the how to achieve the carbon neutrality in bridge construction, basically including the design and construction of the steel bridges. Particularly for the steel bridges, we are working. I'm sure, looking at the presentation now, I will also invite you to join that committee so that your input will be highly valuable over there as to, you know, how do we do that. In addition to that, we are also working on another committee called IRC 9.5. That's a special bridges committee, basically that B9, part of the B9 committee, where we are working on the manual for preparation of the detailed project report, especially for the special bridges, where we would like to include in the DPR itself, to include this carbon footprint evaluation. Perhaps in addition to this, like decarbonization, carbon neutrality, I think we can also talk about this after effects of climate change, like that the impact on the design due to the changes in the temperature, likely changes in the temperature. Of course, a lot of studies have to be done. That also can be done. I think in that committee you are there anyway as a subcommittee member. I think your input, after having seen your presentation, I think your input will be more and more input will be welcome in that particular preparation of the manual of detailed project report. So we are all working on that, and I would like to throw open for the panel discussions. We have got Mr. Alok Bhowmik over here. Alok Bhowmik would like to add on to what what Dr. Lakshmi Parameshwaran, our colleague in many of the committees, has
Yeah.
discussed so far.
Yeah, actually nowadays, whenever there is any webinar related to climate change, I make it a point to attend, because that subject is really of huge interest, I find. And I was really amazed by the presentation given by Dr. Lakshmi, which showed, how much of research she has done on the subject. She has touched upon several important areas for which are worth considering for our core committees.
Yes.
She talked about also a little bit background of why climate change occurs, what provision is there in current codes and how they are deficient, why we need to, she talked about the mitigation measures as well as adaptation measures. Both she covered quite well. She also informed all the participants about the new IRC guidelines which are there for highways and bridges. Of course, you have touched upon what is in the pipeline. So as it is, as I can see, there are a number of issues which she mentioned, which was highlighted, and it only illustrates the fact that each of these areas are, areas where multiple actions are needed. And I really, I do not know, considering the large amount of uncertainty, though she has pointed out the areas of concern, but when it comes to codification, you will find the enormous problem in doing that because of the lack of statistical information available. Nobody is denying the fact that there is a impact of climate change. That is a hard reality. But how it is to be quantified for future designs is a very real challenge, I tell you. I was recently, I had attended one webinar where eminent people like Montek Singh Ahluwalia was talking about the climate change. And you see, what he focused is that climate change is a global issue, we all know. And the interesting part is individually we can do very little. I mean, whatever is going to happen, it has to be a collective action. And collective action not only in India, but collective action across the globe. And I was just, I just would like to share one very important parameter which he mentioned. He says, based on some research, that there are 14 key parameters, indicators, which globally is being tracked all over for each country and all over the world. And these performance indicators, I will just share. It says that out of these 14, as of today, only one is on track, and that one is related to participation of the private sector in self-realizing a goal. For example, there are many cement industry in the private sector. They have given a goal of, we will become carbon net zero by say 2040, not in 2070. They have their own self goal. And these globally, not just India, is on track. But there are 9 such key indicators which are off the track, which includes, this removal of fossil fuel. We are talking about the energy, switching over to the renewable energy, electric vehicle, etc., etc. There are 21 indicators which are very much off the track as of now, which includes, financing for climate, or the, there are many things. I don't want to get into that. That's not important. And there are 6 parameters which are moving in the opposite direction. So if you take a stock today about our goal of 2070, I mean, this I'm talking globally. If we today take a stock of our goal for 2070 to reduce, to become net zero, the challenges are manifold. And unless something is done in next 10 years or next 5 years to sort of bring down the impact of climate change, to take some positive actions, it will be very difficult to meet the 2070 target itself. And so therefore, I mean the huge work is required to be really done, both in mitigation as well as in adaptation. But overall, it was an excellent presentation by Dr. Lakshmi, and I think, as you said rightly, she should be inducted in our committee B5.3 for taking some positive steps. Thank you.
Thank you. Thank you for your. I'll take some questions. There are some questions in the question and answer bank before coming to Dr. Dhawan. Dr. Dhawan, if you permit me, I'll take some questions from the question.
Please continue.
Mr. Amrit Minas is asking Dr. Lakshmi that what about the thing is, he said that we have understood that there is a climate change effects which increases temperature, there is a volatility in the temperature, and of course that the cyclones are there, the flood levels will increase, all these things are happening. But in that case, how do we address the problem about the existing bridges which were designed 30, 40 years ago and or even older than this? What is your take on that?
Yeah, I think those structures will definitely have effect, and I think we need frequent inspection and maintenance of the structures, and especially, as I told, the components like expansion joints, bearings, etc. Otherwise, also I think those elements are giving a lot of problem for the bridges. So and also I think corrosion, that is also increasing. So I think we may have to spend more on I think bridge maintenance management. Yes.
Okay, I think the bridge maintenance management is a very, very important aspect.
Important. Yes.
Especially in case of the highway bridges, like to certain extent, our railway bridges are being, they have got a regime of maintenance, a well-defined regime of maintenance. Perhaps there also, from what you explained, I think from the point of view of sustainability and also the climate change, I think some of the parameters may have to be added there too, even in the railway bridges. What I see is, I think we'll have to have a different kind of maintenance regime formulated for both highway bridges as well as this one. In fact, I'll tell you that one of the problems we find in case of the bridges is we are writing this in climate change, carbon neutrality for this steel bridges code or the guideline. What we find is there is no definite maintenance regime, specified maintenance regime. Unless the specified maintenance regime is there, it's very difficult to do this life cycle impact assessment, and how many times this overlay has to be changed, and whether the one lane has to be closed during the how many hours it has to be closed. There are so many aspects where the maintenance regime has to define it. Unless there is a defined maintenance regime, unfortunately, it's not there in India. And if it is there, it is possible for us to come out with the life cycle impact assessment unless there is a maintenance regime is there. So as you rightly said, I think perhaps going forward, we will have to really look into this. We'll have to take this maintenance very seriously, and we'll have to have
also some funding to be earmarked for maintenance of bridges, because now we are focusing in developing our highway network. But I think the maintenance of this network also needs to be.
So that has to incorporate this sustainability aspects.
Yes.
What you explained. And unfortunately, it's in the hands of the policymakers. Like that's not in the hands of designers or a builder or even a researcher, for that matter. What I see is, and the policymakers have to take it seriously and introduce that very seriously. There's another important remarks. I think it is Dr. Suresh Kumar. I think maybe it is from the RWDI, Suresh Kumar. I do not know.
Yes.
It is the same.
Yes.
It says that, yes, there is a climate change happening, storms frequency and potentially intensity is increasing. However, the wind data measured as well as generated based on Monte Carlo simulations do not show any increase in the speed in comparison with our wind speed map of IS 875. In fact, at many locations, there is already cushion in our wind speed already to take care of the potential increase in the speed due to climate change. This is our finding from our own studies. Maybe it is the case so far, but I think going forward, the climate change effects will not be same. I think there is a study which has to be done very systematically, in my opinion.
Yes.
What is going to be the climate change, especially the cyclone? I think the storms and the cyclone may affect the windstorm. It's a good news. What Dr. Suresh Kumar has brought into our notice. What he's saying in principle is on a conservative side. Basically, our wind loading is on highly conservative side. It is already padded up with a lot of factor of safety. What I can infer from Dr. Suresh Kumar's statement over here, but it is not going to be the same. As we have seen in the last year or so, the way the climate change effects are accelerating. It is not it is what they call it's accelerating to a large extent. I think unless there is an arrest on the climate change effects going forward, I'm not sure that the wind effects also due to the cyclone and storms will be remaining the same, but we'll have to be safeguarding ourselves. But it's a good news. What I see is the wind is not getting affected right now, as per the studies of Dr. Suresh Kumar, it looks like. There is another question from Ikan Biswas, and he's our regular, the attendee to our workshops. I'm very happy to see the questions from him always. And the replacement of carbon steel by GFRP also reduce the carbon footprint. Effect on durability of GFRP on concrete need to study in Indian climate. Before Dr. Lakshmi answers this question, I would like to bring into the notice of Biswas. Dr. Lakshmi is an author of one of the quotes which has been brought out on GFRP bars, the glass fiber reinforced polymer bars. We have brought out a quote right now. It is being used only for the non-structural elements. We are recommending because we want to introduce it in a long way to even for the structural elements. But right now it can be used for the non-structural element in case of the bridges. Say, for example, you have got an approach slab. It can be used even for the PQC, where the connectivity of the two elements is there the bars are used there. It can be used, and also the crash barrier, if I'm not mistaken, we are recommended for the crash barriers also. It can be used, and of course the effect of durability of GFRP on concrete, I think already the studies have been done. I think Dr. Lakshmi would like to throw some light on that.
Yeah, I think we have included even the deck slab, because deck slab is one where it has been used in many of the bridges abroad. So we have included deck slab also, because basically we have included because it has a strength in the longitudinal direction. So that's why we have included this bar for the deck slab. And durability aspect, basically it will be corrosion free, and also there will be some saving on the cover of the concrete also. And some studies, I understand that they are being done, some more research work, you can say, that is being happening. I think in IIT Hyderabad, I heard a presentation from Professor Suraj Prakash. And also I understand that some work is going on in IIT Chennai, Dr. Radhakrishnan Pillai. He is also doing some work. And I think other, I'm not very sure about. And but definitely some studies we have proposed even in that guideline, that unless we do the study using the material which is available in our country, we will not gain more confidence so that it can be used in our structures. Yes.
Yeah, the GFRP bars is certainly more sustainability or a green reinforcing material compared to that of the steel which we are using. There is no doubt about it. It is from the durability consideration also, it's proven well that is a highly durable material. one of the practical problems we face when we are discussing in our committee, we thought is that GFRP bars right now, which is available, it cannot be cut and bent at the site,
Yes.
That is one of the practical problems which we are using. Once we get the GFRP bars, which can be cut and bent like any other HYSD bars or the mild steel bars at the site itself, I think it's going to be extensively used in India. That's what I feel. But I think to that effect, the technology has to be improved. We should be able to cut this to the requirement and bend it to the requirement. Like otherwise, it has to be manufactured at the factory itself to the required site with the necessary, like the bent and all. That's one of the problems in using the GFRP bus right now.
And also the bent up portion has a lower strength than the straight portion.
Correct.
So there are many aspects which needs to be considered if you are incorporating that in the design. Yes.
Absolutely. And Dr. Suresh Kumar has gone on to say that I'm wondering how aerodynamic treatments like guide bands and the damping system will be helpful to take care of the climate change effects, as this could have been already enforced for a particular bridge with the correct climate data. So essentially, we are after whether any change in wind speed with respect to a return period is the question. Thanks for the great talk. I think she has given a bouquet to you, and I do not know whether there is a question here. It's just a statement from Dr. Suresh Kumar.
I think this, as you said, that I think we need to study about the wind speed, what will happen with this
Yes.
climate change. But I understand that some of the bridges, like long span bridges, like cable stayed bridges, etc., now this climate change hazard, that is also being considered in the design. So with respect to that, these are some of the general measures what we have suggested, the aerodynamic measures which can be adopted to make the structure for the wind resistant design of the structure. That is what we have said. But again, now like there could be some thunderstorm and other thing which can happen. So like that probability is also there. Probably I think we need to study more in detail about like how the wind speed is going to vary over the country. Yes.
Hegde Saab, can I come in on this?
Please.
Hello?
Please, Alok, please.
Yeah.
please.
So I just wanted to mention, you see, from Dr. Suresh's comments, it gives a feeling, and of course I know the background, that the current IS 875 provision of the wind is perhaps a little conservative, and that's why he is telling that even if this cyclone is there, it will be accommodated. Now here the point is, there, you see, when we talk about the mitigation measures for climate change, one of the important thing is to reduce the over design, or to sort of make sure that we end up with a a just quantity. We don't over design, and I think if there is a provision in the code which is felt to be over conservative, first let us reduce that and increase only where it is required.
Yeah. Alok, you have turned the argument on its head now.
So first and foremost, we have to work towards reducing the material consumption,
Optimization of structure.
optimization of the structure, use new material. For example, carbon fiber in stay cables is one of the new concept which can be used in long span bridges. Japanese have used this butterfly, webs, where the total, in case of long span concrete bridges, they significantly reduce the dead weight. These are concepts which already in other countries people have used and tested. I think first and foremost, we should embrace those ideas in our structure, and also look for new materials like ultra high performance, UHP, FRC, and things like that. So that should be the way forward in my view.
I think Dr. Suresh Kumar will be happy to hear me now, because you see that from the sustainability point of view, at least in my, the guideline which we are bringing out, where I am a convener, I am going to suggest very strongly that if you do the wind tunnel testing, and if your result is coming, like the effect is coming less, I'm going to insist in the code, in the guideline, that has to be used rather than taking from the codes, which is already specified. Otherwise, after having done the wind tunnel testing, also if the effect of the wind forces, which is coming and the structure is less, we should be taking that. Rather, that is the more sustainability of approach. But I'll try to, try to insist to be brought out in our course. Let's see to what extent I will succeed, but I may not succeed from the next point which you have raised. Like that, what you are saying is educating the public, including the developers and engineers, are very important, since the upfront expenditure may be more to address this issue. Our design is typically on the fast pace with no time, no money to do any elaborate study. So I agree with you that a lot of education is required. From that point of view, I'm saying that even now, I think even if we are doing the wind tunnel studies, if the forces are coming less in reality in the wind tunnel studies, we are insisting in the course that you will have to follow. Whatever is given in the wind codes, whether it's IS 875 or another code which has been brought out by, which is going to be brought out by Dr. Lakshmi. I think she also is going to insist, even if you get the wind tunnel studies, that whatever the forces which are getting, if it is lesser, you'll have to take as per the code. But let us say, I think that's not a sustainable approach. I think we'll have to really look into that. We will see that as to how do you go about it. No doubt, I think the education is a must, and that is one of the reasons we are organizing this kind of webinars, that on the climate change by Dr. Lakshmi and all. I hope more and more people will be participating from the public developer side as well as the engineer side. We do not see that, unfortunately. That's a very essential way to go forward, even to encourage the sustainability, or for that matter, even to achieve the carbon neutrality by 2070. And Divya Agarwal is thanking Lakshmi for making aware of the aspects of the climate change effects and the climate action, potential climate action, which are to be considered. She says that what are the factors we take into account for managing carbon footprint in coming futures, along with the study of carbon emission, and make construction site net zero or diesel free. I was wondering if we should work on wildlife as well. Do you have any thought on it? What factors we need to be considered while doing feasibility study or detailed design to manage carbon footprint? I thought she has given a lot of climate action suggestions. I think Dr. Lakshmi would like to take this question.
Yeah, I think some more detailed studies are required. I think she has given some suggestions. I think we can consider that, and maybe we can try to do what can be done. But definitely this IRCSP 133, that can be useful for estimating this carbon footprint, especially for the road construction and maintenance aspects.
So I'm coming to the end of the questions in the question and answer bank. And I will tell you that ING IABSC, Indian National Group of IABSC, is coming out with a Congress in September 2023. And that I think people can go through this IABSC website and see that is majorly concentrating on the sustainability aspects, and the theme is on the sustainability aspects. I suggest most of the people who are participating here should take an opportunity to go through this IABSC website, International IABSC website, where they are called for the papers even, all the themes of sustainability. All of you can, provide the papers, you can submit the abstracts, and the abstract submission date is extended up to, January 31st to enable the people. I think going forward, sustainability is going to be the integrated part of this any design as well as the construction. I think that will be the main aspect. That will be one of the criteria for even awarding the jobs in future. That will become what they call it as a quality-based, the bidding system. And in that also, I think that the sustainability aspect will figure in. I think all of you should attend that particular IABSC Congress, which is going to be held, which is theme is totally on the sustainability. I think you people not only should send the abstracts and write papers on that, and you people should be participating in that. I think that will be very, very enlightenful. I can say that. And with this, I think I have come to the end of all these questions. And Dr. Lakshmi, would you like to add something before I hand over this podium to Dr. Dhawan for closing remarks?
Yeah, I'm grateful to the participants for giving a lot of input, and somebody has given in the chat box that I think the construction aspect, because climate change, how it is affecting the construction, that has not been dealt. Probably the work what you are doing for the steel bridge construction, that will be dealing with that. I'm sure that there will be more, as I informed earlier, this is just, you can see, a preliminary study. So probably more detailed studies are to be done in each of these aspects. So that is a work which will be continuing. And I thank Mr. Hegde for doing this moderator job very efficiently, and also giving more thought on this particular subject, and Mr. Alok Bhaumik for giving another perspective, like about how challenging it will be, and we have to work together to achieve this net zero in 2070, and what part we can play here. And Dr. Dhawan for definitely giving, motivating to give this sort of lecture. Thank you very much. Thank you all.
Thank you, Lakshmi, for giving an excellent lecture. I know, in spite of your not good health, you have devoted so much time reading new research papers, and gave an exposure. Of course, it's a preliminary study, and more detailed studies by other researchers need to be done. And you explained, I think, so beautifully the effect of climate change and its mitigation needs and adoption needs. And so thanks on behalf of institutional engineers for sparing your valuable time, particularly for the benefit of young structural engineers who has got to do more and more in optimizing not only the design, the durability part and the maintenance. So the overall concept of structure, not from the conceptualized stage to the completion stage, but particularly thereafter monitoring, health monitoring, through health monitoring, keeping a watch of the safety of the structure. Now, before I close, the next lecture on 23rd February, Mr. Vinay Gupta will be talking on the new topic. And on 23rd March, Mr. Hegde, again, our experts, so more and more experts, I'm grateful, will be sharing their valuable experience to the young engineers. So let the young engineers participate and gain knowledge and apply that in the near future. Thank you once again to everybody who has participated. Thanks to Lakshmi ji for giving a wonderful lecture. So thank you, everybody, once again.
Thank you very much. And we are all signing off today.
Thank you.